Sorry, totally forgot to start recording. Thank you. But don't worry, there's recordings of this as well. So with pseudocode, the binary search, we're going to create a method that takes in a target number, a sorted array, and a tracker index. We need to find the middle index of the array and round down and store it to like a middle index variable. If the target equals the middle index, we just return the index that the value is found at. The target is less than the middle index. We're going to split the array in half from index 0 to like the middle index, so wherever it's split. Index 0 to middle index, and repeat. Else, target value is greater than, I'm going to split the array in half from middle index to array length. And then, but we have to, and which one do we have to pass in the middle index? So we need to pass in, so this tracker index, we need to, anytime we grab the right hand, we have to pass that tracker index to the argument. We have to grab the middle index and pass it in as a tracker argument. With middle index passed in as target or tracker. That's it, right? So it should show like, yeah. Here's my other pseudocode. So create a method that takes in the target number, sorted array, tracker index. You need to find the middle index and round down if necessary. Find the middle number, sorted array by grabbing the middle index. If the middle number equals the target number, then tracker index plus the middle index. Okay. So it's like return. The length of the array is less than or equal to 1, so that's an edge case. The target number is greater than the middle number. Return the right array. Tracker index. Let's code this real quick. Let's do target number, array to search through, and tracker index. If there isn't a tracker index passed in, let's just default it to 0. So the middle index equals, we need to grab the length of the array to search through. And how do we grab the floor, like the round down? Down by 2. Then let's grab the actual middle number of the array. So array to search through, middle index. So it's going to grab the actual element at that index. The first thing we're testing, if target number equals middle number, we want to return, what do we want to return then? We want to return the middle index. Middle index. Let's see if this works. Well, let's just assume that it's going to be sorted when we pass it in. So up here, it just says, say you're searching through for a value number in a search set of sorted values. Elif length of the array. So this is an edge case, length of array to search through, less than or equal to 1. Then we just want to return -1. Oops. Return -1. Elif target number greater than middle number. What do we want to return if its target number is greater than the middle number? That means we want to return the right side of the array and pass it through. So we can return binary search. We're going to pass in the target number and the array to search through, but we want to grab the left half of that, or I'm sorry, the right half of that array. Is it middle? Yeah, the middle index. Can it just be middle index? Let's look it up.
Middle index and then semicolon. That should bring it to the end.
I'm going to print array to search through, middle index. I'm going to grab test. Print binary search. So we really want, our target number is 9, so we want to grab the right hand side of the array so it actually comes into here. Let's see, so what should our array be? Should it be 5, 6, 7, 8, 9? Python. Oh, I do that all the time. None. Array to search through. Say it's colon.
Yeah.
5, 6, 7, 8. That's what we want, right? Why did none get printed? There we go. Cool. So this takes it from the middle index and colon, just colon that just to the very end. And then we have to keep track of the index throughout the recursion process as we're calling itself. So we need, what's our tracker index?
Do you want to add 1 to the middle index as well, since you're already checking to see if the middle index is equal to your target number?
Say that one more time.
So you already, your first if statement already checks to see if that middle index is the target number. So back on line 33, your middle index, since you no longer need to check that index. So would you want to add 1 to it just to further reduce that search array?
In here, the target, the tracker?
Just the middle index number. Since your middle index,
Oh, let's see. So right now, the middle index. Comment this out. So middle index is 4. 1, 0, 1, 2, 3, 4. So we need to keep track.
So like if you do middle index +1 when you grab that, when you pass the array, then you don't
I
check
see.
5 again. I think that's what he's saying.
So 679. You can do that. I think that would work. I've never done that. I haven't done that, but yeah, I think that like logically that makes sense. Yeah. But I'm just gonna pass in the middle index. So I just want to say, but yeah, that makes sense. So binary search comes in here. So now we just don't want to. We actually want to the middle index plus. Well, we'll get to that. Else, what is it? If target number is less than middle number, we want to return binary search. Get rid of this print statement. Target number, same, array to search through, but we want to start from index 0 to middle index because it's not doesn't include it.
Or middle index.
I'm sorry, like that, right? I just want to print the array to search through just to see, make sure. I like printing everything. Anytime I'm writing code, just print it. How's that? No. So since we're never grabbing, let's grab 1. Or the target number is 1. So 1, 2, 3, 4. Cool, because that's what we want. Like that. And then what do we pass in for the target number? Or the tracker index? We do anything? Just tracker index? So yeah, because we still want to pass in. Well, the middle index, let's just run this, see what happens. 1. Where's this print statement? So return, print this, if our logic is right, let's test it. 0, that kind of easy, because if we do 2, 1, if we did 8, 0, 1, 2, 3, it should be 9, right? Still 1. So we're not adding the tracker index because we want to keep track. We're not adding the tracker index up here to the middle index. Because the middle index might be 1, like, because as we're breaking down the array, the indexes are going to be smaller and smaller. So we need to continue to add the tracker index onto this. See this now. 3, that's still not right because we need to add new tracker index equals middle index plus tracker index. And we need to pass in new tracker index. So it's continually growing. Does this work now? Is that right? No. 0, 1, 2, 3, 4, 5, 6, 7. Oh, okay. Oh, sweet. That works. Is there an error in one of these test case specs? Or no? Yeah. Oh. Let's run this to see this test array works. Python, binary search, back. All right. I print this stuff. Cool. Here's a sorted array. How do I sort the array first? Does it automatically? So is this a destructive method?
I think it's sorted ed for Python.
Yeah.
Sorted and then your whatever your array is.
Oh, snap. So I have to store this in another variable?
That's just sorted.
You have to pass in whatever your list you want sorted.
Sorted and then parentheses. I don't think there's a term sorted. I think sort in place and sorted.
So sorted and then let's try it out.
It's sorted.
I'm gonna look it up. Sorted in Python returns a sorted list of all specified arable and specified. So I can do that. Will it actually change, or do I have to?
No, it'll return a shadow copy of it.
Okay.
So you have to say that.
Right, to search through. All right, we sorted it. Hopefully it's actually sorted. I'm down here. All right. That's binary search. Sorry, I forgot to start recording. I'll send out a couple of review videos of it actually recorded all the way through. What questions do you have with regard to recursion or anything like that?
I don't know if this is necessarily with recursion, but it kind of goes back to our technical interviews. What's kind of like the thought on using built-in functions versus like actually writing out the logic behind the built-in function?
They'll say don't use built-in methods, or if like, oh, there's a sort. They say, you know, write a sorting algorithm to sort this array, and you're like, oh, well, that's easy. I can just do sorted. They're like, well, don't use the built-in method sorted. But I would say use built-in methods until they tell you not to. Or you can just ask them, like, hey, there is a sorted built-in method. Do you mind if I use that? And they'll be like, you know what, try to sort it on your own. But like things like push pop, like shift, unshift, like manipulating arrays isn't, like you can use built-in methods for that. Like that's normal. When you're on the job, you're not going to have to create a brand new sorting algorithm to, you know, I don't know, check something. Unless you're doing like hardcore data science and searching through massive databases in which you need a very efficient sorting algorithm, because sorted might not be the most efficient. You can probably look up what the OLN of this method is in Python, I think.
Yeah, it returns an array, passes ed, it's a keyword argument, and reverse the keyword argument to reverse it.
So yeah, like I don't know what's going underneath on the hood in the Python language, what it's actually doing. I don't know if it's just like iterating or whatnot. right? But like, what's the actual sorting algorithm that's being used? Is it like quick sort, merge sort, something like that? Quick sort. All right, if nobody has questions, I'm going to stop the recording and take another 10-minute break. Be back at 9 or 10:05. 12 minutes.